So average value of a function. Average value of a function. Let's draw a picture. Kind of go from there. So any graph you want, make it, I guess, sort of look like mine. Some f of x from a to, whoops, let's make that a to b. And we want to find the average value between a and b. Between or on a to b. So like the average height of that, the average height of that function. Well, I don't know if you're going to like this initially, but I don't know. Maybe right there. Let's call that the average height. F of C. I'm going to have to kind of work backwards to figure this out. So somewhere at C, the average height is F of C. I contend that the average value is f of c if there's my f of c height. If this red area purple, whatever color that is, if the red area equals the black area. Basically, we're going to derive this formula. We're going to come up with this formula on our own here. Does that make sense? Because if f of c is too high, then those areas wouldn't be equal. If f of c is too low, the areas wouldn't be equal. There's some spot in there that makes the area of the red rectangle equal the area of that black shape in there. We good so far? Yes, no? Vaguely? 2 out of 10? Let's see, the red area then would be a rectangle. So width times height, b minus a times f of c. And the black area is the area under a curve. So we could represent that with an integral from a to b of f of x dx. And we've already claimed that f of c is the average height. So let's get that by itself. And all we need to do is divide by b minus a, although we almost always see it written this way, 1 over b minus a out front, and then the integral from a to b. So the Average value is the total area divided by the width. The total area divided by the width. And now you see why we do it here in the curriculum, because now we know how to do antiderivatives. So average height is area over width, and you know how to find area. This is one of those big deal equations. So that's why, rather than just giving it to you, I tried to give a little bit of background on how we found it. Maybe that'll help it stick in your brain. Total area divided by the width gives you the average height. Now, put that to the side for a second. We're going to talk about MVT for integrals. MVT for, do we need to remind ourselves what MVT for derivatives is, though? Probably. MVT for derivatives, maybe you remember this picture, says that somewhere the actual derivative is equal to the average derivative. Somewhere the calculus slope equals the algebra slope. Is that familiar? It's maybe familiar now that I rewrote it. Calc slope equals algebra slope. And the idea was that C, and I guess this was the main conclusion, if that's true, C is between A and B. It has to be. That's the conclusion of MVT. In the mean, in the middle, somewhere between A and B, there's a C such that the calculus slope equals the algebra slope. So MVT guaranteed that C was in the middle. MVT for integrals, it's going to be one of those same but different kind of deals. If f is continuous on A to B, there exists C on A to B, so that part's kind of the same. Like MVT tells us there's a C in between A and B. For derivatives, it says that the calculus slope equals the algebra slope. For integrals, it tells us that the average value so there's the average value. The average value happens at a place. The x value is between A and B. So the conclusion is kind of similar, like C exists between A and B. For integrals, it's that the average value happens between A and B. For derivatives, it's that the slope happens between A and B. And usually these problems are written in two parts. The first part is find the average value, and the second part is find where that happens. So it's like find the y value, the height, and then find the x value where that occurs. So let's say f of x equals x squared plus 1. And let's find the average value on 0 to 2. Well, let's draw a little picture to see if we can understand what's going on here. So x squared plus 1, that's a parabola moved up 1, or you can plug in points. So 0, 1, 1, 2, 2, 5. And so we want the average value between 1 and 2. Any guesses on what you think the average value will be? Give me a guess. What's that? 2? Okay. I mean, that point's on there because I plotted 1, 2. But it could be the average value. So 2 is not a bad guess. Any other guesses? What's that? Like more than 2, you think? And I mean, right now I mean the y value. So what's that average height? In between 2 and 3? Put your name on it. What do you think? Give me a 2.5. Okay. Anybody else want to hazard a guess on what they think that average value is? All right, let's see. So average value is the area, the total area divided by the width. 1 over b minus a, integral from a to b, f of x dx. Just rewriting it so my hand writes it one more time and my brain sees it one more time. So the width is 2. Integral from 0 to 2, x squared plus 1 dx. So let's see, that would be x cubed over 3 plus x from 0 to 2. So if I plug in 2, I get, let's see, 8/3 plus 2. And if I plug in 0, we get 0, so that's kind of nice. That is a safe stuff, but I kind of wanted to know, like, well, what is the value there? Let's see, 8/3 plus 6/3 is 14/3 times a half is 7/3. And 7/3 as a decimal. I mean, 7/3 is our best answer, but as a decimal, just to see how we did on our guess, it'd be 2 1/3. So you guys were close. 2, 2 1/2, somewhere in there. Turned out to be 2 1/3. So there's our average value. And the next question, I hope you don't have to, but the next question is always find C guaranteed by the mean value theorem. Guaranteed by MVT. So C is the x value that gives the average value, or the average height. So that means there's some C value. If we plug it in, our answer is 7/3. On the picture, it It means where does it happen? It's guaranteed to happen between 0 and 2, and our picture kind of confirms that. So we need to set f of c equal to 7/3 and see what we get. I think we're going to get something between 1 and 2, but we'll see. So the function was c squared plus 1. So if we subtract 1, we get 4/3. If we square root both sides, that would be plus or minus 2 over the square root of 3. What do you think about that answer? Or answers, that's 2 answers. So back at the picture. Think about those 2 answers. It's supposed to be on 0 to 2. Are both of those answers between 0 and 2? I saw 1 yes and 1 no. Dia, why not? It's negative, so the negative one's definitely not between 0 and 2. If you don't know what 2 divided by root 3 is, well, I don't either, but I know the negative one won't work. 2 divided by root 3 is 1.15, so we're good with that one, but that negative one we have to throw out. On 0 to 2, only the positive one. Again, if we care, that's about 1.15. That's just to sort of confirm to ourselves that it works. Again, almost all these questions are 2 parts. Find the average value and find C where that happens. Let's do one more. F of x equals sine of x on 0 to pi. And it's going to be the same 2 questions. Find the average value. And then we'll find where that happens. Well, a picture is not required, right? I mean, you could just set up the formula. The average value is 1 over pi minus 0, integral from 0 to pi, sine of x dx. That's the average value, which is fine, but I think a picture is helpful. Hopefully you remember what the sine of x looks like. That's what we're doing in pre-cal right now. Those graphs. What's the maximum sine gets to? What's the tallest it gets? So any guesses on what we think the average value of this will be? Well, careful. We're going 0. I was a little misleading here. We're only yes, 0 to 2 pi. The answer would be 0 for sure, because those 2 areas would cancel each other out. But we're only looking for 0 to pi. So that was a little bit misleading to include that. So any other guesses? 0 would have been right. 0 to 2 pi. How about give me a range you think it's going to be? I just want to make sure you're like understanding the concept here. What's it definitely between? It's definitely between 0 and 1. Is it based on that picture? Do you think it's closer to 0 or closer to 1? Can you tell by looking? What's that? It looks like there's because of its concavity, basically. I think there's a lot of area in there. I think it's going to be closer to 1. I think it's going to be more than half. But we'll see. But absolutely between 0 and 1. There's no way it's more than 1. There's no way it's less than 0. Let's see. Integral of sine. Antiderivative of sine. Yeah, it's cosine or negative cosine, but it's negative cosine. From 0 to pi. So that's 1 over pi, and then negative cosine of pi minus negative cosine of 0. Lots of negatives to keep up with, which means I probably should have taken the negative out to start with, but oh well. Cosine of pi, oh, I got even more negatives to deal with, is negative 1. So negative negative 1 minus negative cosine of 0 is 1. I definitely should have taken the negative out to start with. That's okay. Positive 1 and positive 1 makes 2. So 2 over pi is my official answer. Now I'm just curious. 0.637. So between 0 and 1, absolutely. A little bit more than a half. Yeah, because it's kind of mounded up like that. So that's my average value. Part B is always going to be the same thing. Find C such that f of C equals the average height. Or find C guaranteed by the mean value theorem. Well, the average height we just found, that's 2 over pi. F of C would be sine of C. Uh-oh. Glad we have a calculator handy. If the sine of C is 2 over pi, how in the world do I figure out what C is? It's been a long time. How do I figure out what C is? Yeah, inverse. So inverse sine of 2 over pi is 0.690. That's supposed to be between 0 and pi. Pi is 3.14, so yeah, I believe that. This is a tricky one because there's another spot. There's 2 places that give us the average value. But the calculator only gave me one of those spots. Can you tell by the picture how to find C2? Pi minus the first one. That's the inverse sine rule, but you may not remember the inverse sine rule, but hopefully you could tell by the picture the symmetry there, that C1 from the calculator, C2 sort of from the picture. All right, today's assignment is the worksheet on average value. I'll post the answers. They're not posted yet, but I'll post them soon. The good news is tomorrow is a very easy lesson, like super quick. Might even finish the worksheet before you go. So if it feels like it's starting to pile up on you tomorrow, it's like, okay, I can do tomorrow. And then you'll have the weekend to sort of catch your breath from all we've done this week. And then there's one new thing next week, and then the test is next week as well.